Okay, so this is a video for factoring part 2. You guys need your factoring flipbook, and we're going to fill out the last 4 tabs of our flipbook. So the topics that we're going to look at are factoring trinomials of ax squared plus bx plus c, where a is not equal to 1. Difference of squares, where you have something squared minus something else squared. This one's a binomial. Perfect square trinomials, where you have ax squared plus 2 times an abx plus b squared, and factoring by grouping. Okay, so just like we did last week, you're going to flip it up. So we're going to start with factoring trinomials, ax squared plus bx plus c, where a does not equal 1. And so there's a lot of methods to doing this. So I'm going to do first, I'm going to show you the box method. Now, you may remember that I showed you how to FOIL with a box, something that looked like this. Well, we're going to factor with the box. Okay? So to begin with, you have to do a modified diamond. So instead of doing just the C here and the B here and figuring out what multiplies to make the C and adds to make B, we now have an A, and that A value is going to affect everything. So you're going to multiply the A times the C, and that's what goes in the product part, the top. And the sum is the same, it's still the B. So we're looking for two numbers that multiply to make the product AC and add to make B. So let's say that those numbers are E and F. So how we do this in the box is the AX squared term is going to go in this box. Okay, so that's the one that I have colored green there. And the C is going to go diagonal from that. Then the other two things, the other two boxes, are going to be BX, but they get broken up into EX plus FX. Remember the E and the F. Remember that E plus F will equal B. So EX plus FX will equal BX, right? So it doesn't matter which of the diagonal, these can be swapped, it doesn't matter, but those are going to go there. And then what you do is you factor out a GCF from each row or column and row. And those numbers go there because it's the reverse of the factoring or the foiling box that we did. Okay, so let's look at an example. Let's say we're doing 2x squared plus 9x plus 9. So the first thing you need to check for is that there's not a GCF that's going to make the A turn into a 1 after you take the GCF out. And in this case, we're not going to have a GCF here because 2 doesn't go into 9 or 9, right? Okay, so we're going to start with the modified diamond problem. So you have to take the 2 and the 9 and get the product of those two things, and that's 18, and that goes here. And then this 9 is going to go here. So we're looking for two numbers that have a product of 18 and a sum of 9. And those two numbers would be 6 and 3. 6 times 3 is 18, 6 plus 3 is 9. So now we're going to set up our box. So the 2x squared would go here, and the 9, this 9, would be diagonal from that. And then the 9x is getting broken up into 6x plus 3x, using this and this as the coefficient. And it doesn't matter, like I said, where you put each of them. It just doesn't matter. Okay, so now we're going to look at each row and column to find GCF. So I could start with this column right here and look for GCF that goes into 2x squared and 6x. Well, they both have at least one x, and 2 goes into 2, and 2 goes into 6. So remember how this works. We're multiplying inward So whatever multiplies times 2x needs to give you 2x squared. And so that is an x. But you could also just look at this row here and say, what's the GCF? Oh, it's x. So it works both ways. I like to do the GCF for 1 or 2 rows, and then from there I just go and say what times what will give you 3x, right? They have to multiply inward, and that would be 3. And then I do 2x times what gives me 6x. Well, that would also be 3. And then you can check 3 times 3 would be 9. So these are positive, so it's like there's plus signs in between. So that's your answer. You have two binomials, a 2x plus 3 and an x plus 3. Okay, this is the box method. Alright, so I'm going to give you another one. I want you to try it on your own. So example 2. Okay, so here's your example. 4x squared plus 7x minus 15. I want you to pause the video and try to do this process on your own. Okay, so this is the setup. You got to do a diamond problem. Two numbers that multiply to make negative 60 and add to make 7 are 12 and negative 5. So then we put it in the box. Okay, check to make sure that you did that part right. If you did, awesome. Go ahead and do the rest of it. If you didn't, fix it. Go ahead and pause it and fix it, and then keep going. Okay. If you did it correctly, this should be your answer. Now, these two binomials can be swapped. That's not important. It could be x plus 3 times 4x minus 5. All right, I'm going to show you another method, and I'm going to use this example that we just did to show you a different method. Okay, now this method, I'm going to give you a warning. Okay, it's easier, but people get it wrong a lot because they forget to do the second step. And if you don't do the second step, you're going to get it wrong. Okay, if you don't commit to doing all of the steps, you're going to get it wrong. But it is easier, but it's easy to forget that second step. Okay, just remember that you can always FOIL your answers to check to see if your answer is correct. Okay, so here's how it starts. It starts with the same first step, the diamond problem. The modified diamond where you have to multiply. So then you go ahead and you do x plus the two numbers, so 12, and x, well this is negative, so minus 5. Warning, warning, this is not the answer. This is not the answer. This is not the answer. This is the answer, right? Okay, and I say that because people just stop there and think that's the answer, but it's not. If you FOILed x times x, you would not get 4x squared. You just wouldn't. Okay, so there's a second step. So here's the second step. You take the 4 and you divide both of these numbers by that number. If it reduces, for example, in this case, 12 divided by 4 is 3, you would reduce that. If it doesn't, you would take the denominator that's left and put it in front. And we get the same answer. Doesn't matter that the binomials are switched, okay? But you have to remember to divide by the a, otherwise the whole thing will be wrong. Okay, difference of squares. So difference of squares is when you have something squared minus something else squared. Specifically a squared minus b squared. And so it factors into a formula. Whatever was being squared first, in this case the a, is going to go into the parentheses first, and the b, which is the second thing that's being squared, goes second, and then we have 1 plus and 1 minus. So I could show you why this works very easily by FOILing a minus b times a plus b. A times a would be a squared. A times b would be a positive a times b. Negative b times an a would be a negative a times b. And then a negative b times a positive b would be a negative b squared. The ab and the negative ab would cancel because you're basically multiplying the same two things together, but with one with a minus and one with a plus. So they're always going to cancel. And so we just get a squared minus b squared. So the process to these, let's do an example, is first identifying what is being squared. So let's say we have x squared minus 64. You got to know your squares pretty well here. X squared is an x being squared, obviously, but 64 is an 8 being squared. So the two things that we have that are being squared are an x, which is first, and an 8, which is second. The order is critical because when you put them in the parentheses, you have to put the x first and the 8 second. Now, it doesn't matter the order, the plus and the minus. I put a minus plus here, it could be a plus minus, it doesn't matter. There's your answer. Done. So this is a factoring one that's more of a formula. Let's try another one. How about you try this one, pause the video, and then see if you got it right. So go ahead and pause the video and see if you got it right. Okay, so first of all, you have to recognize it's an x squared minus a 12 squared. So it's going to be x plus 12, x minus 12. Did you get it right? If not, try to analyze why. Did you not know what 144, that 144 was a square of 12? So just maybe check out all of your squares. Okay, so let's do a harder one. Let's do 25x squared minus 1. So now the thing that is being squared here is actually 5 and an x in parentheses. Okay, when you're multiplying two things, you can distribute a square like that to get it 25x squared. Then the other thing is 1 being squared is 1. So 1 is a square of itself. It's got an unusual property. Okay, so the first thing that goes in front, oops, I was about to make a mistake there, is a 5x and a 5x, then plus 1, then minus 1. Okay, I'm going to show you one more example. Let's do 500 minus 5x squared. So at first you may think this doesn't have squares, right? 500 is not a square, 5 is not a square. But the number one rule of factoring, I don't know if I've mentioned this yet, is always look for a GCF first. And in this case, it equals 5. If we can take the GCF out first, what we're left with may be of the type we're thinking it is, so difference of squares. And it is, because 100 is a square of 10, and x squared is x squared. Also notice that the order is backwards here, and that just means we have to put the 10 first and the x second. And don't forget the 5. The 5 has to be outside in the answer. So the 10 was first, put the 10 first in the parentheses. X is second, put the x second in the parentheses. Give one of them a plus, one of them a minus, call it a day. Okay, so that's two types. The next type is the perfect square trinomial. So this comes from, so perfect square trinomial. So this is under the perfect square trinomial flap. This comes from squaring a binomial. So the format that I gave you up there, ax squared, actually I forgot, it's an a squared, sorry. It's an a squared x squared plus 2abx plus b squared. So what that comes from, and this is what the factoring is if you have an ax plus b in parentheses, that's being squared. Okay, now the number one rule about squaring a binomial is you cannot, and I repeat, you cannot square the two things on the inside, add them together, and call it a day. This is one of my biggest pet peeves. You cannot do that. Now up here I was telling you if you have 5 times x, you can kind of distribute a square, but that's multiplication. We have addition. Okay, so no, 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 no. Okay. All right, so what can we do? Well, to square something means to write it multiplying times itself. So what it does equal is ax plus b times ax plus b. It's multiplying times itself. That's the definition of a square. Okay, so if we FOIL this, ax times ax would give us a squared x squared, because the a times a and the x times the x, plus ax times b, which I'll call a times b times x, and then I get another one of those, b times ax. Again, I can put the order of the letters in any way I want. Multiplication, order doesn't matter. So I'm going to put it so that they're the same, abx, abx, and then b times b would be last, which is b squared. These are going to combine to 2a times b times x. And so that's where we get this. So essentially this is a formula one. To factor this, you just go ax plus b squared. It's a formula. That's it. That's what it looks like. But you have to, the hard part about this one is checking to make sure that you actually have this. So let's do some examples. So we have 4x squared plus 12x plus 9. So you could factor this exactly how we did these types, because that's essentially what they are. They are trinomials of the form ax squared plus bx plus c, where a does not equal 1. Okay, but you're going to find that knowing this shortcut is going to be handy. It's going to save you a lot of time. Okay, so first we have to check to make sure that you actually have this type. So you want to look at the coefficient in front of the x squared. Is it a perfect square? Yeah, it is. It's 2 squared, right? So that's the a squared in this. Then look at the number at the end, the constant. Is it a square? Yeah, it's 3 squared. So that's your b squared. So then you have to take these two numbers, the 2 and the 3. That's your a and that's your b. And then what you want to do is you need to check if you have 2 times a times b as the coefficient of the x. So do we have the 12 here? Is that 2 times our a times our b? So let's check. 2 times our a times our b would be 2 times 2, that's our a, times 3. Is that 12? Yes, it is. So it works out that this is the correct form. You need to be careful to check that middle number, because if it was like an 11, the whole thing wouldn't work. It has to be a 12. So once you recognize that you have this form, then we can put it into the form ax plus b squared, which in our case, our a is 2, so that's a 2x, and our b is 3 plus 3. This is your answer. Okay, let's try another one. By the way, I didn't mention it, but you can have subtraction sign here. If this first plus was a minus, then this right here would be a minus. This will always have to be positive because it's a perfect square and it can't be negative. Okay, so let's try one with a negative. Let's do 36x squared minus 60x plus 25. So now I made the numbers a lot bigger, and that would make it much more difficult to do the box method or the method, either method that we're doing up here. Because your modified diamond would have to be well, first you have to multiply 36 times 25 and put that number up here, negative 60, and it's like, ew, right? Okay, so if we recognize that we have perfect squares, check it. 36 is a perfect square. It's 6 squared. 25 is a perfect square. It's 5 squared. So that would be your A and your B. If this works out, and remember the negative we don't have to worry about, we're just checking to see if it's 60. So 2 times 6 times 5 would be 60. So it checks out. So the minus sign just means the sign in the middle is going to be minus. So our answer is 6x minus 5 quantity squared. The 6 goes here, the 5 goes here, the minus goes here, and that is going to be so much easier than doing this way. All right, we're in the home stretch. Last one, factoring by grouping. Okay, so factoring by grouping is going to have 4 terms. 1, 2, 3, 4 in order to work. And it's a variation on a GCF. It's just your GCF's a little bit more complicated. Okay, so you're going to need 4 terms. And what you're going to want to do is you're going to look for a GCF in 2 pairs. Now this is not a method that's going to work for everything with 4 terms. You just have to see if it works. So is there a GCF between x cubed and 9x squared? Yeah, there's x squared. And if I take out x squared, I have an x plus a 9. Okay, then bring down that plus, and then look for a GCF of 2x plus 18. Well, that's 2. So then what's left is x plus 9. Now, if factoring by grouping is going to work, these 2 binomials that you get need to be identical, because those are going to be your GCF. Now this is where it's a little weird. You can have a GCF that's not just a number or a monomial, it can be a binomial GCF. And so we are going to factor out that GCF. Now it's going to make more sense if I show it to you as if it's not a binomial but something else. So I'm going to replace x plus 9 with a. So I'm going to just say x plus 9 equals an a. So when I replace the a here, I'm going to get x squared times a. I replaced this with a plus 2 times a. Do you see now that a is a GCF? We can take that a out, and what's left would be 2x squared plus 2. Okay, now remember, we didn't really have a. We had x plus 9. So if I put the x plus 9 back, you'll see the real answer. Okay, now if doing this a thing helps you, then by all means you could do that, but you don't have to. I just think of it as I'm going to pull out the x plus 9. Now the GCF is just one x plus 9 that they have in common. So don't write it squared or anything like that. And then I'm just writing what's left after I pull that out. And what I have is x squared plus 2. And that's what's going to go here, just like it was over here. Okay, that's factoring by grouping. Now remember the first one we went over today. I showed you the box method and I showed you this other method, which I don't really have a name for. There's also a factoring by grouping method. Okay, so I'm going to show you the factoring by grouping method. So 2x squared plus 9x plus 9. Now this is not 4 terms, this is 3 terms. So I'm going to show you how to factor this, which is a trinomial where a is not 1, using the factoring by grouping method. So as with all the other methods, you have to start with the modified diamond. So 2 times 9, 18. Put the other 9 here. We get 6 and 3. So the difference here is now you are going to take the 9x and you're going to write it as 6x plus 3x. And you're going to bring down the 9 and the 2x squared as they are. So now it becomes 4 terms. And this is where the factoring by grouping comes in. Look at the first 2 terms and the second 2 terms and take out a GCF. You would take out a 2x here and you'd be left with x plus 3. Here, bring down the plus, you take out a 3 and you'd be left with x plus 3. You see you're getting the same thing here? That's your GCF. So we pull it out and we're left with 2x plus 3. So remember what our answer was using the other method, the box method? We get the same thing. So these are all variations on factoring this, but feel free to use whichever method you would like. Okay, that's it for this video. The rest of the week you just need to do your homework for 5-4. There's a 5-4 part 1, part 2, and there's a 5-4 quiz, and that's all you have to do for this week. Okay?